Hello everyone, welcome back. Digitrax Dad here. Tonight I'm continuing to wire up our digital command control drawer with all our control boards, Digitrax products and our CML now Signatrak, who've taken over CML. This is their SIGM20, SIGM20 signal control board, which contains the logic in there to control between 8 and 10 signals. At the moment I've got it wired up for 8. So I thought I'd show you how we are going to wire that up today. So let's get stuck into it. Okay, so before we get stuck into it, these are the tools we're going to use tonight. First and foremost, we're going to use the Dymo here. This one prints onto heat shrink tubing and is excellent for printing out heat shrinks so you can identify your cables. We've got our scissors to cut that. We've got our side cutters here for cutting wire. Our ratchet cam action wire strippers. Got our jeweler's screwdriver here for screwing in the connections. We've got our crimpers for putting our bootlace crimps on, and we've got our heat gun for basically heating up the heat shrink tubing from the Dymo so that it shrinks onto the wire. So we'll see how that works shortly. What I've elected to use for some of the smaller gauge wire that doesn't have the larger currents flowing through it like the block detection boards is to use a ribbon cable like this. So this one here has a female connector already terminated on each end. It's about, I think it's about half a metre, 48 centimetres long from memory. This one has 34 wires in it, so it's got 34 connecting pins, 34 wires through it, and this basically plugs into what they call an IDC connector, which is this male socket here, which you open out these two tabs on the end and then simply press to fit the ribbon cable end in. Those connectors then lock up to hold the female connector in. And then this can then go wherever you need it to into the layout itself. So as the drawer slides, this will move backwards and forwards. So it's an effective way of using low current and low distance so you don't get any voltage loss. So to help do that, what we've got to do is wire our signal board up. The IDC terminal block here, this was a purchase from China off of a well-known auction site. I think it was around about sort of $13 Australian, including delivery. I've ordered 4 of them. And basically you've got screw terminals here numbered 1, 3, 5, 7, 9 through to 33, and then 2, 4, 6, 8 right through to 34. That's your total of 34 wires that can come into this particular connection and out via these pins. So what we've done is look at the groups of signals. This is signal 1, signal 2, 3, 4, 5, 6, 7 and 8, along with common anode or common cathode, depending on how your signals are wired. These are then grouped, and then I've brought all of these signals here, these 4 signals along this right hand side, have been brought forward and wired into the block detector on the right hand side here. And what we're going to do is wire up these 4 on the left hand side and wire them into the blocks over here on this side. What you'll see also is that to make things easier, I've color coded the wires so that green wire, yellow wire and red wire correspond with the green, yellow, red outputs of the SIGM20 board, and also then that will correspond with the wires that go to the signal LEDs. The black wire will be the common wire, which will be a common anode in this particular case for these particular signals that I'm wiring up. Alright, so let's crack on with doing some wiring. I'll put the common in first. So how we'll wire these up is signal 4 here, which will be red, yellow, green on 34, 32, 30. Black or the common will be on 28, and 26, 24 and 22 will be for signal number 3's red, green and yellow. So we'll just keep that out of the way for now while we get this one sorted. So first thing we do is need to cut this one to length. I like to leave a little bit of slack there and hold that close to where it's going to be going, and then just snip that off. Put that aside. we'll get our wire strippers, place that in there like so. Get our bootlace crimp and basically twist that on, which twists the wires, gives us a good connection there. Crimps on. Get our crimpers, place the crimpers like so, squeeze, we've got that now nice and secure. I like to trim these a little bit, they're too long to go in as they are, so I just trim a little bit off of the end like so, and that's ready to put into the screw hole. So 28 is what I said I'm going to do. So get number 28, feed that in like so, and screw that into position. That's our first one done. Come over to the third one, signal number 3. We'll put a little bit of slack on that, and we'll cut that to length just before the tag there. Signal 3. I like to keep that to one side so I remember which signal I'm working on. Now I do the stripping. Green into here, strip, red, and yellow. Time for our bootlace crimps. Okay, first crimp on. That's crimped into place. Next crimp. Yellow. As I may have said before, the reason for crimping these wires is that it gives a much better connection, permanent connection with the screw terminals, no stray wire strands, and helps assist in preventing oxidation. What we don't want to do is solder these wires, tin the ends of them and then crimp them. That crushes the soldered wire, and it's a likely chance of a problem with the electrical connections over time. So a pure mechanical connection with these crimps is the best solution. Trim these all now to length, like so. So let's print off a heat shrink label. Okay, so this dymo device here called the Rhino 4200 is the low end of the dymo market. Once again, not going to do a full review on it, but look up Rhino 4200, and as I said, it comes with a number of cartridges like this one, which is a permanent vinyl, black on white lettering, range of sizes up to 1 inch, which is great, so you can get some very thick ones. This is a 12mm normal vinyl, black on white. It's a thermal print rather than a ink print, which is great. The other thing too about this one is that it does take the heat shrink tubing, so we're going to print out some heat shrink tubing just now. So I've turned it on. You can see where there's one previously in here, so let's pretend we're starting from the start. The signal number that we're working on just now is signal number 3. Lucky, because I kept my little piece here, so I know it's signal number 3. And so we basically SIG3, hit print, and press cut, and we have a heat shrink tube printed with SIGM3, signal number 3 on it, and as you can see, we can thread our wires in there, and then we'll heat that one up, and then thread this over the wires ready to apply the heat gun. So we'll get that over the green and the yellow wires first, then thread the red wire up through like so, I find it's best now just to rotate the wires, get them in the order that you want. Ready. Okay, which is green, yellow, red. Let's get them screwed into position, and then we'll apply some heat to this. Okay, so we move our heat shrink label, just slide that along so that we're happy with where it's located on the group of 3 cables. What you will find with the 6mm heat shrink tube is that it's a little bit on the large side even after it's been compressed up to 3 times its size for a single one of these wires, but just fine for a group of 3. We then take the heat gun here. This one's just got 2 heat settings. I find a single setting is more than enough, and simply turn that on and apply it. Now we can see our heat shrink label is nice and secure, signal number 3, so we know we're in the right spot. Alright, and there you have it. So that's our SIGM20 board, wired up for signal operation. Now, you're probably saying, well, where's the power? Where's the Loconet connection? Absolutely. Look, there's the power supply. That will connect into these 2 wires up the back here. All pretty straightforward. And from a Loconet perspective, basically we're going to use a Loconet cable, not dissimilar to this one. So we'll be plugging into our Loconet ports here at the back of the board, and which are upside down on a SIGM20 compared to the orientation on a BDL or a PM42. But there you go, that would be hooked up, power into here once I hook that up. And yeah, but that's the IDC, all nice and neat. You can see where they are, and we're not putting any strain actually on these connections on the board. This stays static, and as the board moves in, the connection sits over here. So I think it's a good result. Any questions, give me a shout out down below. Send me a question, and look forward to getting back to you. And yeah, hope you're enjoying the videos.